Today?
Good.
You guys know what we're doing?
No.
Yes.
Good. Well, that means I'll just explain it to you for the other half. So what we're doing today is we are installing the vertical axis for a wind turbine. And we're going to put up a 30-foot wind turbine here at this school so that we can really understand how alternative energy can work together to eliminate the need and the carbon footprint produced by the farm that we put in the library. So what we're going to do is install a vertical axis 2,000 watt wind turbine with 5-foot blades so that we can use the power of the wind to create electricity to charge batteries and use those batteries to power the aquaponics system inside. Now, do you think that's going to be enough?
Yeah.
Maybe, right? Maybe. What if the wind stops blowing? So the other piece that we're going to add is we're going to create an electrical hybrid. We're going to add 500 watts of solar panels and allow those solar panels to reap the power from the sun that we can also use to create electricity. So we'll have the electric from the wind turbine at 2,000 watts. We'll have 500 watts of solar energy. And then in the library itself, we're installing pedal-powered bicycle charging plants attached to the same type of alternators that are in your cars. And as the motor spins, it creates electricity to keep your battery charged, run your lights, and all of that. So what we're going to do is create a reading station that allows you to pedal the bikes and charge those same batteries, creating an airline system that's powered from those batteries to keep your fish alive. And so what this is doing is creating a zero footprint farm. Do you guys know what zero footprint is?
Yes.
No, that means that you're not using any wasted electricity, you're not using any type of carbon emissions, right? So typical farms will have diesel fuel to run generators, diesel to run tractors, and they'll use, water from the aquifers to eliminate that. Well, we know that aquaponics uses about 10% of the water as traditional agriculture. So by coupling this system with an alternative energy system, what we're doing here at Cooper Middle School is creating a zero footprint farm. And there's only a couple of those in the entire world where the amount of effort going into the farm is actually less than the amount coming out of the farm. So what you'll be able to do is compare the value of the wind speed and how much energy it creates. You'll create the value of the solar energy and find out how much energy it creates. And then you'll be able to compare that to how much energy it takes you as a human being and resident on planet Earth when you're pedaling a bicycle to find out how much energy you can create. And so working in teams, you'll be able to power this system independently with any one of those three power systems. However, having all three of them work together, you'll be able to monitor and understand how alternative energy can truly make an impact in our society as well as feed people. So if we're going to feed 20 million people by the year 2020, and we know that we're going to have 10 billion people here on planet Earth by 2050, the job for you guys is to understand how to harness this alternative energy to create the power that you need to lead healthy, happy, successful lives. So 10 billion people, right? 10 billion people by 2050. How old will you be in 2050? Do the math. 47? 47 years old. So by the time you're 47 years old, you'll have a need to feed that many people. But you won't have one extra drop of water on planet Earth, and you won't have one more bit of arable land on planet Earth, but you'll have 3 billion more people. So in order to understand how to use our resources more effectively and use planet Earth more effectively to our benefit, instead of using tractors to do the farming, let's use natural resources to create energy programs that allow us to understand and improve what farming systems look like. So today we're installing a wind turbine tower. It's heavy in math. You'd think that we're just going to put a pole in the ground, but today what we're really doing is we're doing a massive geometry problem and a mechanical engineering problem. We have to figure out how to balance 80 pounds of wind turbine in the air on a 1.5 inch pole, and what type of weight would be necessary underneath that pole to keep it from falling over or getting pushed like this and like this in the wind. Obviously, we can look at these trees and see that the wind is moving those trees. Is it going to move a pole too? Yes. So we have to think about that level of motion and put weights in place and pin it specifically in the ground so that it can be held in place securely and doesn't topple over. So that math is basically finding the momentum, or finding the moment that is equal to the wind pressure. So what's the average wind speed here? These are factors that you need to consider when you're putting in a wind turbine. So how high is the pole? 30 feet. So we know that we have to balance that pole at a 90-degree angle and then attach guy wires at a specific angle that can be figured out just by you guys using simple math here. Great. You guys have any questions for us before we get started?
No.
All right, well, let's build a tower.
All right.